Hello, class, and welcome. Today we're going to be working on graphing the inequalities instead, so it's similar to what we were doing the last few days, but slightly different. So as you see, we do have a bit of a warm-up right now, so go ahead and give that a shot. You have negative 3x plus 15 is strictly less than 45. So go ahead and solve it for the following. All right, so you see that we have the negative 3x plus 15, 45. What we're going to do is actually move that 15 over, subtract it from both sides. So when we do that, we can actually just have negative 3x is strictly less than 30. Divide both sides by that negative 3, flip the sign, x is greater than negative 10. So this should be kind of familiar with what we've been dealing with. A little bit of an older style of warm-up, not as animated, but it should be fine. All right, so we're going to be working with inequalities on one variable. Day 2, we're going to be dealing with graphing today. Compound inequalities are coming up next, and that will be a handout first. So, create and solve inequalities with more than one variable, interpret the solutions, and identify the inequalities just true or false based on the number of solutions. Warm up. We have the same vocab from last time, so we're not going to spend too much time on that. We have a discussion. Break is a little bit old. That's from last year. I forgot to adjust that, so XA on that. So, a bit of review. You might be asking, why is there a measuring cup up here? Okay, well, just think about it for a second. We'll make sense of that in a little bit. We have the strictly greater than and less than signs. We also have the greater than or equal to or less than or equal to signs. So this is where this measuring cup comes into play. All right. So when you have a measuring cup, think of it this way. When you get a cup of liquid, that's what we normally put in measuring cups, or it could be somewhat solid liquid like peanut butter. Some people put those in there, etc. When you want a cup of it, do you fill that line or not? Well, if you want a cup of water, you fill to the line. See the line, fill the line. So if you see a line, you're going to fill the line and fill the bubble. So we're not filling the bubble on this side, but fill the line, fill to the line, or see the line, fill to the line, fill that bubble. It's a good way to keep it in touch. So I went ahead and selected some problems we are not doing for homework, and we're going to work through the process on the next few slides about how to get through it. All right. So 17 is one we're not going to do. It's a bookwork day, but we're supposed to solve and graph 5x plus 15 is less than or equal to negative 10. So make sure you write out exactly as is, so we know what we're dealing with. And if we realize that, hey, 5 is positive, so we're going to keep it positive. So we're going to move this 15 over. All right. So we're going to subtract that 15, ink, ink. And we're just going to clean up a bit. Well, 5 minus 15, that's going to get us a 0. Then negative 10, negative 15, those will add since they're both negative, getting us negative 25. Last step is we need to divide both sides by that 5. So both sides by the 5. And what's that going to get us over here? Cancellation on one side. And then a reduction right here on the other. So we have a 5. All right. So x is less than or equal to negative 5. I will always recommend to put it in this form if at all possible, where x is on the left, whatever else is on the right. X on the left, whatever else is on the right. Okay. I've been having some issues with that. I hope it's still going okay. Okay, so let's go ahead and fill that in right there. So we see that we filled in a bubble at negative 5. Now the question is what way do we need to go? Since we're at negative 5 here, we can always just inspect some elements nearby, like the negative 6 and the negative 4. Negative 6 is less than or equal to negative 5. Remember, they're negative, so a larger number when it's negative is actually smaller. The more you get this way, the smaller you get. The more you go this way, the bigger you get. So in this case, negative 5 is bigger than negative 6. Okay? negative 5 is bigger than negative 6. So that's true. While negative 4 is bigger than negative 5. The second one's false. So that tells us we want to head off this way. So let's just go ahead and go off that way. Notice this kind of looks like an arrow, right? So we have this negative 5, we fill it at negative 5, and it kind of looks like an arrow pointing off towards this direction. So that should tell us that we want to go this way on the negative 5 to the left, as long as we have x on this side. So that having an x on this side will give us this arrow kind of idea to see where we want to go. All right, so let's go ahead and keep on going. 21 is another one that has fractions. Told you they like fractions, so these ones are back. So let's first write down the problem as is. So we have 1/4 x is strictly greater than 1/2. Let's take care of the fractions first by multiplying by that 4. So when we multiply by that 4, we're actually going to distribute it through. So the 4 is going to come down here and come over here. From here, we're just going to write it right back up here and realize that we can just cancel right here and here. Sorry about the glitches and stuff like that. The dock station's having some issues still. So that just gives us that x. 4 and 2. Well, 4 divided by 2 is going to give us a 2 up here. And then we just have 2 times 1 giving us 2. So notice, no line, don't fill that line. And we're going to bring it over to 2. So it's an open circle at 2. And notice now the arrow looks to be pointing towards the 2, but this is also saying x is bigger than 2. So logically, 3 is bigger than 2, so we would want to use that. So think of x, it's on the left, and of the arrow. And realize we go to the right. So if you set it up like this, more times often than not, you can use this as a way to point at which direction you want to go. The arrow's pointing this way, the arrow's pointing this way, kind of thing. All right. So solve and graph negative 3/8 x minus 20 plus 2x. So notice we have a couple x's on this side, and we'll go from there. First things first, write down the problem, what we're dealing with, number for number. I was having issues with the inequality, try to write them down, helping people. Reading them upside down can sometimes cause them to flip. But I digress. Let's go ahead and realize that 3/8 is significantly smaller than that 2. So we're just going to move the 20 over for now. Okay. So let's add that 20 to both sides. By doing that, we're going to get 3x plus 2x is strictly greater than 6 plus 20, or 26. Let's bring that up to the other right up here. All right. Now, we could combine these, or we can realize that we have this 8 down below. We want to really take care of that 8. All right. Multiply both sides by that 8. So when we multiply everything by the 8, this is what's going to happen. Distribute the 8 through. Dink, dink, dink. All right. So we have the 8 down. Now we just start simplifying. Well, the only place we really have to simplify is right here, right? 8 divided by 8. That's gone. That just leaves us at negative 3x. Now we can start combining like terms, or not combining, like simplifying, like 8 times 2 and 8 times 26. So pause here for a moment in case you need me to write that some down. You can also pause the video and come back to this. But let's just go ahead and pull this up. So we're going to take this, pull it up here, and then we're going to continue finishing up on it. 8 times 2 gets us a 16, and 8 times 26. Before we do that, you realize we're going to get this number to be really big. We could make a big number huge, or we can just have a look here. Let's just simplify a little bit more on the side of it, okay? So 13x is bigger than 8 times 26. Notice that there's something oddly familiar about this. 13 and 26. So let's divide both sides by that 13. So when we divide both sides by that 13, notice what happens. 13s will cancel, and then we're just left with 8 times 26 divided by 13. 26 is divisible by 13, and we can replace that with a 2. So 8 is bigger than 8 times 2, which is 16. So we're going to have an open circle at 16. Doesn't look open, but it's an open circle. And which way are we going? Well, we want to be bigger than 16. 17 is bigger than 16, and the arrow's kind of facing that direction. So off towards positive infinity we go. So you see the arrow method does help and does work. You do have one that says this: solve the inequality and how many solutions. So we want to bring that down and have a look at it. Realize that 4 and 8 are the numbers we're looking at. 4 divides 8 and 8 divides 8, so we can use 8 again. So let's just go ahead and use that 8. All right, so we're going to distribute the 8 through and simplify. Bring it down here, 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 and here. All right, so from here, what we're going to do now is start simplifying slightly. 8 and 4. 4 divides 8 twice. 8 and 3, we'll worry about that a little bit later. But let's just bring it right up here for right now, after we simplify. So what's 8 times 3? Well, that should be 24. 8 divided by 8, that should be 1 times, because negative 7 x, because the reason it's at negative 7x is 8 divided by 8 is 1, and we're going to times that 1 by negative 7, so we get that negative 7. And 8 times negative 2 gets us a negative 16. So let's simplify a little bit further and gather like terms, like that negative 2 and positive 2 and negative 7. All right. So we get negative 5 plus 24 is strictly less than 16. We'll get there a little bit further. We're going to get to the same answer, but going a couple different ways. So that's what that means. Next slide, we're going to see the same answer, but going 2 different ways. So we're going to take this last little bit. Negative 5x plus 24 is less than negative 16. And we're going to bring it up and work with it 2 different ways. All right, here we go. So we're going to start with the left-hand side. And what we're going to do is simply move the 24 over and leave the negative symbol. So when we do that, we're just going to subtract the 24 from both sides. Canceling the 24's here. So we have negative 5x, subtract 16, subtract 24. And you can add those together to get negative 5x is less than or equal to, strictly less than negative 40. But when we divide by that negative 5, we have to make sure we flip that sign, and we'll do so in a moment. So what we really have is x is larger than 8. Now, so this guy is highlighted, so we're going to be moving that around. For on this one, we're going to move the x instead. So we're going to add the x to both sides. So 24 is less than negative 16 plus x. Add the 16 to both sides. So when we add the 16 to both sides, again, we're going to get 5x on one side. And here's that 40 again. Notice the x is bigger on this, and the x is still bigger on this one. It's just the equality is just facing the other side, and the x is just on the other side as well. So we're going to divide by that 5 again. And when we do that, lo and behold, we get the same answer. X is bigger than 8. 8 is less than x. Same exact answer. So it's just one solution because we were able to get to this. It wasn't having the same quantity. We were able to determine that once we got to this stage right here. The negative 5x plus 24 is less than negative 16. There's no x on this side, so we would default to one solution. Okay. The other problem I gave you is similar to this. A solution is graph. Describe any changes that need to happen. So we look down here, we see that the graph would have been, this is problem number 44, by the way, is saying that -5 is, we're looking at values that are bigger than -5. So let's just go ahead and have a look at this. Go through the problem, make sure that no mistakes were made. So first things first is, well, we could divide this off. By dividing this off, it'll be dividing this by -2 and then dividing this by -2 as well. But let's just go ahead and go the distribute route. So we're going to distribute that -2 here and here. So -2 times x gives us -2x. -2 times -5 is positive 10. What do you notice about this? We have -2, -2. So this is case what? Case 2. In the statement, positive 10 is bigger or equal to 10. Is that a true statement? True. We just need to fix the graph to contain all numbers. So let's just get rid of that and contain all numbers. Done with that one. All right. So let's go ahead and have a look at the next one as well. So we are going to be looking at some keywords when building inequalities. If we have A is more than B, know that is strictly A is bigger than B. A is at least B means A is greater than or equal to B. A is less than B means A is, well, less than B. And A is at most B, or A is no more than B, says A is less than or equal to B. So it's just a way to look at these inequalities and have this kind of keywords for word problems. So here's an example of a word problem. Suppose you are employed at a sales job and pays you $30,000 a year in salary, but you also earn 5% of your sales in commission. A commission is if you sell something, you get a percent profits. This is common in like auto industry. This is also common in like Avon and other industries like that. So if you want to earn 50,000 that year, how much must you make in sales for this to be a reality? So you want to earn at least 50,000. So that's why we're bringing the 50,000. And what else do we have? You know that we get 30,000 plus that. So 5% turns into 0.05. 30,000 plus 0.05. We have all the information we need. We just need to subtract 30,000 from both sides. Let's kick that on over up there. Implies we have 0.05 is bigger than 50,000 minus 30,000 or 20,000. Now we're going to divide both sides by that 0.05. Another way to write it is 2 million divided by 5 or 400,000. So you need to somehow make $400,000 in sales. That's, at least in this town, a very hard thing to do. To make $400,000 in sales under this particular employment. So that's a lot. So you see, it's not going to be, it's going to take a lot to make this. All right. So let's carry on. If you're using the online program, the online version of the basically questions, this is another way you might run into these. Right now, what we have graphed here is x is less than 3 and x is greater than -2. So you see from -2 onward, less than 3 onward. So another way of seeing this is using that parenthesis. And another way of seeing this other one is using that bracket. Okay? So you see why there's a reason we kind of covered the parentheses and stuff like that. All right? Classwork is page 28, 12, 22, 24, 26, 28, 35, 40, 43, and 48. So that's just another way we see it. We'll cover a bit more in those in the future. Have a nice one. Once I get to here.